Hello there, hello. Welcome to CXC Math TV. And today we're going through the Pure Mathematics Unit 2, Paper 2. And this was the June 23 paper, the recent paper. Alright, so summer is over and it's now back to work. Alright, so we're going through the Paper 2 part. Alright, so question 1. Of course, Module 1 is complex numbers, differentiation, and integration. So question 1 starts by saying, a point Z moves in a complex plane such that the magnitude of Z minus 2 minus 3i is equal to the magnitude of 4 minus 2i minus Z. So the first thing when you're doing complex number is, alright, since it asks about, it says what? Sketch the locus on the Argand diagram. You have to remember when it's in this form, the locus is a perpendicular bisector of the line connecting point A to B. Once it's in the form Z minus A equal to magnitude of Z minus B, then the locus is a perpendicular bisector of the line, and remember it's of the line joining A to B. Alright, that's it. So in this case now, A, this is the point, A Z minus A. If we just factor out the minus, it's really magnitude Z minus in bracket 2 plus 3i. So in that case, it's telling us our point A is, the real number is 2 and the imaginary part is 3. Alright, so that's 2, 3. Alright, so I'll just use my axis. This is, let me see. This real number is 4, so the furthest it goes is 4. So this can be 1, 2, 3, 4. It doesn't matter. This is the axis I want to use. Minus 1, minus 2, minus 3, minus 4. And then now the highest it goes up here, let me see, positive 3, negative 2. So I can go 1, 2, 3. Oh, no, I can't do that. I can go 1, 2, not what I want to do. 2, 4, 6. Because here I want to go minus 2. Yeah, this of course will be minus 3. Alright, so now remember the first point here is 2, 3. The real part is 2 and the imaginary part is 3. So this would be 3. So I'll put my point right here. And that's the first point A. Now this right here, it's in the form B minus Z. Alright, but that's okay because it's also okay. The same, because it's magnitude, it's also the same as Z minus B. Alright, it don't matter. Alright, so if you say the magnitude of 5 minus 2, that would be the same as the magnitude of 2 minus 5. Alright, so don't worry about it being in flipped form. So in this case now, the point right here, the real part is 4 and the imaginary part is negative 2. So in that case now, we're looking for 4, negative 2, which is right here. Then now we're going to draw a straight line. Or we can use dotted lines. Let's use dotted lines. I don't know how to get the dotted lines, or I don't remember. It's been a long summer, a nice vacation summer. So, all right. And then now we need a line that bisect it, and bisect mean cut in half. Bisect mean cut in half. So, cut it in half. In between 2 and 4 is 3. So now it is at 3 and it's at this point. Alright, so now this right here, I'll cut in half. Alright, this is not so wonderfully straight. I'm trying to get it wonderfully straight. Uh, Alright, we get the gist. It's a sketch. Alright, it's a sketch. Alright. Then of course let's label the blue line and tell them this blue line, this is the locus. The locus. Very easy. This is the answer, the blue line. Alright, nice and easy. That's all for today. How many marks for that? 3 marks. Of course, 1 mark for each of your points and then 1 mark for your locus there. It's easy. Alright. Now it says determine the Cartesian equation of the locus. You could do it 2 ways here now. So method 1, since you already sketch it, you could just find the equation of the line. The equation of the line, remember the locus passed through the midpoint, and then you could find the gradient of this line. Alright, so remember, it's in the form y equal mx plus c, and then you take it from there. Now, I don't want to start with method 1. That's not my preferred way. My preferred way is method 2. Alright, so start by writing down what they gave us. So they gave us, remember, magnitude of z minus 3 plus 2i. Actually, 2 plus 3i. 2 plus 3i. I don't know if with the earphone I'm hearing myself so well, so I'm going to remove the earphone. 2 plus 3i. Alright, so yes, I'm hearing myself a little bit better. Alright, I wasn't hearing so well. Alright, and then over here now, it's equal to 4 minus 2i minus z. So magnitude of 4 minus 2i minus z. In this case now, you have to first remember, wait a second, you have to substitute z as x plus yi. So we're going to put x plus yi where z is, minus 2 plus 3i, equal, over here now it's 4 minus 2i minus z, and z is x plus yi. Make sure to use good use of your brackets. And then, in this case now, right, we need to group up real part and imaginary part. So grouping up real part, this is x minus 2, plus grouping up imaginary part, this is yi minus 3i. Factoring out the I, this is y minus 3 times I, magnitude of that, equal over here, it's magnitude of 4 minus x. Close up that. Let me write the 4 minus x a little bit better. Then we have plus in this bracket, this is now minus 2 minus yi. So minus 2 minus yi minus y bracket I. That's it. Now remember, what does magnitude mean, right? If you saw this right here, this means, remember, magnitude of, let's say you had a vector a plus bi, or even a complex number a plus bi, right? Magnitude of that. That means the square root of real part square plus imaginary part square. So in this case now, the magnitude is going to be the square root of the real part square, x minus 2 square, plus the imaginary part square, equal, over here it is the square root of real part square plus imaginary part square. Now, as we all notice, because it's square roots on both sides, we just square both sides to cancel the square root. So we square both sides. And by squaring both sides, then we expand the bracket. So squaring both sides, the square roots are going to cancel. And then now we expand the bracket. So this becomes x squared plus, well, this is minus 2 times x is minus 2x. So that would become minus 4x. Negative 2 when you square it is 4. Y squared minus 6y plus 9. So this is just expanding the bracket. expand this bracket. This is 16 minus 8x plus x squared. Over here, negative when you square it is positive. Negative times negative is positive. And negative y when you square it is y squared. Now we just need to simplify. This is basic algebra now. As we can see, the x squares are going to cancel each other on both sides. The y squares are going to cancel each other on both sides. Now we need to group up. Now 4 and 9 is 13. And we have minus 4x minus 6y equal 16 and 4 is 20. And we have minus 8x plus 4y. Now I'm just going to bring everything to one side. Just to make it easier, let's bring everything to the right. Bring over 13, that's 7. I bring over negative 4x, I would have to add 4x to both sides. So if I add 4x on both sides, I notice I have minus 4x here. Then I add 6y to both sides, and I notice that I will have 10y. So now what I have as my equation is, can bring back the y, well, bring the 4x and the 7 to the other side. So this is really saying 10y is equal to 4x minus 7. So I brought over the 4x and the 7. And divide through by 10. So y is equal to, divide through by 10. This is 2 over 5x minus 7 over 10. And this would be your Cartesian equation of the locus. This is it. You're probably saying, well, sir, that don't look like it worth 4 marks, but I find it very easy. All you need to do is remember that you're going to have to substitute wherever. All you have to substitute is wherever you see z, you put x plus yi. Remember, a complex number is x plus yi. So that's it. Determine the Cartesian equation of the locus. Where you see z, you put x plus yi. And then, let me move myself over here. So that's all. Wherever you see z, you put x plus yi. Then after that, it's just algebra, and it works so easy. Now, what you could do is also use the equation of a straight line. You already know C, the intercept. The intercept we had from our graph, if you go back around here, let me go back to the graph. Our intercept is, so hard. This is -1. Let's not use the intercept from the graph. I'm going to use a short point that we know, which is the midpoint. All right, remember it's a blue line. All you need is the gradient of the line. Well, either way, you need 2 points on the line to find the gradient. That's why I wouldn't use method 1. Because again, it's a sketch and it's not so accurate. You tend to run into some problem. Alright, so I'm going to use this point since this point looks very easy to use. That point looks like this is 5, 6, 7. So this is a point 7, 3. Let me see another point that looks easy to use. I like to try to find the easy. I'm going to use the midpoint as well, which looks like 3.5. Alright, so in that case now we have, remember we have 2 points. So this is if you wanted to do it from your sketch to determine the Cartesian equation of the locus, which I wouldn't recommend. I would recommend knowing method 2. So we have point A, which we say is 3.5. And we have point B, which we say is 7, 3. So now we need to find the gradient, and the gradient is y2 minus y1 over x2 minus x1 is 3 minus a half over 7. Well, we said 3 minus a half over 7 minus 3. And because it's just the end of summer and we're not really in that calculating mode yet, I'm going to take out the calculator. Alright, still, you know, a little rusty after summer. So from that, we get 5 over 8. Then remember the equation is y minus yp equal gradient in bracket x minus xp. And remember the sketch is not so accurate. So this is fully correct, you know. This is fully correct. Notice this is given 2 over 5, which is 0.4. 5 over 8 is, that's a different answer altogether. So clearly you can see the sketch method is off. This is from our sketch, so you have to tell them that will be from the sketch. So then it's y minus a known point, y minus the known point half equal 5 over 8 in bracket 3 in bracket x minus 3. And I don't like this method for the simple reason that we're basing it off a sketch, right? But I don't think they penalize you too much, all right? Because you're at that level where you shouldn't be penalized too much. Now this part now, I'm gonna zoom in some more just so it's easy to see. It says given that x cube minus x cube y minus 2xy squared equal to cos xy, determine dy by dx. So we have to do what we call implicit differentiation. We're gonna have to differentiate both sides, which is x cube y minus 2xy squared. Differentiate the left side, and also we're gonna have to differentiate the right side, and that will allow us then to find dy by dx after we transpose for it. So remember, we have to use product rule. Product rule, you keep the first times the derivative of the second. When you differentiate y, you get dy by dx, plus keep the second y times the derivative of the first, which is x cubed. When you differentiate x cubed, you get 3x squared. Minus, let's differentiate now this as a product, the 2x y squared. So look at 2x as a u and y squared as your v. So remember, I'm putting a bracket because of course there's a minus in front of it, so you have to remember, you have to bracket this. So keep the first, which is 2x times the derivative of the second. When you differentiate y squared, you get carry down the power, subtract 1 from the power, then multiply by the derivative of y, which is dy dx, plus keep the second, which is y squared, times the derivative of the first. When you differentiate 2x, you get 2, close up that, equal now, on this side, when you differentiate cos, you get negative sine xy. Alright, but then remember, inside here we notice is what? We have x and y, and that shouldn't be happening. Think of it as cos A then, right? Think of it as cos A. And you're trying to find this derivative. Let's call it g equal cos A. You're trying to find dg dx. To find dg dx, it is dg by dA multiplied by dA by dx. So the first thing we had to do was differentiate it first, or differentiate sine. We differentiate sine, we differentiate cos, we'll get our sine, but then we have to multiply by the derivative of what's inside the bracket. But because it's xy is xy right here, alright? So we realize we have to consider the y, alright? So, but to differentiate inside the bracket again, we realize it's another what? Product. It is indeed another product. So now you think of your x as a u, alright? Think of your x as a u. I guess what I'll do, because I know some persons might be a little confused by scribbling, so let me change that right here. What I'm going to say is let u equal xy. So really and truly what we're saying is like you differentiate cos u. When you differentiate cos u, you get negative sine u. But then you have to multiply by the derivative. You're always going to have to multiply by, du dx, right? You're going to have to differentiate du dx, meaning you have to differentiate xy with respect to x. But then that part we have to use product rule. So I hope I clarified it. So keep the first times the derivative of the second, plus keep the second times the derivative of the first. Now all of this now is just simplifying. So now it's the easy part. This is now x cubed dy dx plus 3x squared y minus 2 2's 4, so that's 4x y dy dx minus 2y squared. Now here's the nice part, because we're multiplying this times this and this times this. So in that case now, this is now minus x sine xy dy dx, and then we have minus y sine xy. Now anywhere we see dy dx, we're now going to have to group these to one side, right? So I just put a dot underneath each one. We're going to have to do what? Group them to one side. So just zoom out a little. So dy dx, I'm going to factor out. From this, it's x cubed. From this leaves minus 4xy. Now notice if I bring this one across, if I bring this one coming over, it would become a plus, and it would have the x sine xy, close the bracket, equal. Everything else needs to be on the other side. So on the other side, we would have our minus y sine xy. When we bring over the 2y squared, it would become plus 2y squared. And when we bring over the 3x squared y, it would become minus 3x squared y. Now to make dy dx a subject, boring part, divide both sides by x cubed minus 4xy plus x sine xy. And anything you do to one side, you have to do to the other. And so this cancel. So now we get the gradient function dy by dx is, I like to write the positive term first. It is 2y squared minus 3x squared y minus y sine xy over x cubed minus 4xy plus x sine xy. That's it. How many marks? I think this worth 5. I would give this 5, because we actually did a lot of work here. Alright, so that's dy dx. Yeah, 5 marks. I knew it worked 5 marks. Do you think it worked 5 marks? I think it's 5. Alright, part C. Part C says, given that 3z squared minus pz plus 2q equals 0 has root 3 minus 5i, determine the values of p and q. Remember that complex roots occur in conjugate pairs. So we can say if one root alpha, so by the way, I'm saying let alpha and beta be the roots. So if alpha is 3 minus 5i, then we know that beta is 3 plus 5i. So then we know that the sum of the roots is going to be alpha plus beta, which is 3 minus 5i plus 3 plus 5i, and 3 plus 3 is 6. That's the sum of the roots. Then the product is going to be alpha times beta, and alpha times beta is 3 minus 5i times 3 plus 5i. Then we multiply them. This is now the difference of 2 squared. 3 times 3 is 9, minus 5i times 5i is 25i squared. And minus become what? Plus. So in this case now, it is, what am I saying? 9 plus 25 is 34. Okay, great. So in that case now, that means the quadratic is given by, remember, it is z squared minus the sum of the roots times z plus the product of the roots equal to 0. So in that case now, it is z squared minus the sum, which is 6z plus 34 equals 0. But they gave us another quadratic equation, which is 3z squared minus pz plus 2q equal to 0. So what we can do is our equation we got, we'll multiply it by 3. And if we multiply it by 3, what we're getting is 3z squared minus 18z plus 34 times 3. 34 times 3 is 102 equals 0. So in that case, what we're concluding then is by equating coefficients. So equating coefficients, you realize that 18 is equal to minus p, and from this right here we have 102 is equal to 2q, so q must be 51. So in that case we get our answer, q is equal to 51. Alright, that's it. So p is negative 18 and q equal 51. That's the answer. Now again, what you can do is test it. Test it. If you do not believe it, check it. In the exam, check it. How do you check it? Look at this. Bring out a calculator and you're gonna check it. So your calculator, you can put in the mode to solve a quadratic equation. I'm gonna put in, I want you to solve this quadratic for me. A is 3. Let's see, it was 3. B is negative 18. And C is 102. We're supposed to get 3 plus 5i and 3 minus 5i. Bam! 3 plus 5i, 3 minus 5i. It's that simple, alright? So you check your answer and you say, wow, that was easy. How much marks for that? 7. The easiest 7 marks you'll get on the paper. Alright, now this question says, using De Moivre's theorem, determine the square root of this expression in radians. Now the key thing it says, using De Moivre's theorem. Please do not use the other method where we say, where we call it v and then was trying to find the square root of v. No, they say use De Moivre's theorem. So what is De Moivre's theorem? Remember, De Moivre's theorem tell us that cos theta plus I sine theta, when we raise it to the nth power, is equal to cos n theta plus I sine n theta. That's De Moivre's theorem, right? So first thing we need to do is put this in polar form, right? Or, yeah, we need to put it in polar form so it is easier for us to work with. And we're working in radians. So in this case, it is 1 minus root 3i. I'm going to call it z. Let's not call it z. Too much z. Let's call it p. So p is equal to 1 minus 3, square root of 3 times I. We need to find the square root of p. So in this case now, the magnitude of p is equal to 1 square plus root. I know you're going to say negative 3 all square, but it doesn't matter, guys. When you square negative or positive, it's going to be positive. So if you say I leave off the negative, don't penalize me and say, sir, you left off the negative. But yes, for principles, I should put the negative. In this case now, we get 3 plus 1 is 4. Square root of 4 is 2. Then now we need the argument of p. Now, first thing I have to consider the quadrant. Now, the real number is 1. And this is negative root 3. So it's in the fourth quadrant. And if it's in the fourth quadrant, it's just tan inverse. So it's tan inverse y, which is minus root 3 over the real part 1. Remember, it's tan inverse imaginary part divided by real part. So in this case, I put that in the calculator. And remember, it should be in radians. So we tan inverse minus root 3 divided by 1. I'll put that into our calculator and we get minus pi by 3. So in that case now, alright, in that case now, what we have is that P is actually, what is P? P is actually, remember it's in the form R, so it is 2 in bracket cos negative pi by 3 plus I sine negative pi by 3. Alright, but then now we know that cos of minus is just regular. So this is now 2 in bracket cos pi by 3 minus I sine pi by 3. Then now we need to find the square root of p. And so the square root of p, which is giving us the square root of 1 minus root 3i, it's equal to, using De Moivre's theorem. Remember, De Moivre's theorem states this. Alright, cos theta plus I sine theta to the n. So what am I saying then is, remember De Moivre's theorem, and if you put the r here, then it's r to the n times all of this. So it's r to the n times cos n theta plus I sine n theta. Alright, I ignore the r because usually most times r is 1. Alright, so what are we saying? We're saying then that if we're finding now, look what we're writing. I'm going to write it out proper for you. We need to find the square root of p, which is 2 times cos pi by 3 minus I sine pi by 3. We need all of this raised to the half power. Remember, it says use De Moivre's theorem, so the next method is not accepted. In that case now, what you're getting, we're going to tell them this is now r to the n, so it's 2 to the half, in bracket, it's 2 to the half, times cos n theta, so it's cos half times pi by 3 becomes pi by 6 minus I sine pi by 6. Then you put that in the calculator. So now we're saying then that the square root of p is 2 to the half power, which is square root 2 times cos pi by 6. You can just put that in a calculator, cos pi over 6, which we should know from ADMAS, but you know, summer just ended, so I'm just as rusty. So root 3 over 2 minus sine pi by 6. I think that's sine 30 degrees and sine 30 is a half. So minus I over 2. Then now you multiply them. So we have square root of 2 times root 3 over 2. And that is what we get. This looks like root 6 over 2 minus this part. Now we'll work it out. It is just going to be root 2 over 2i. And that's one answer. Alright, we'll finish. That's it. Alright, not bad. So that's our answer. Alright, by expressing your answer in radians, and we did everything in radians. Alright, so that's it. That's using De Moivre's theorem. Now this is what you had to do. Please, now I'm just going to do the conventional approach just for those who would have probably done it this way. So if you did this, which is not correct by the way, if you said let's say v be equal to 1 minus square root 3i, and then you said the square root of v is the square root of 1 minus square root 3i, and you said that's equal to a plus bi, and then you square both sides. So this is a conventional approach. Square both sides, and by squaring both sides, now you have 1 minus root 3 I is equal to a plus bi all square. And then now this is 1 minus square root 3i equal first term square twice the product of the two, become plus 2abi plus second term square. Bi, when you square it, it really become minus b square. Then you group real parts. By grouping real, 1 is equal to a square minus b square. And grouping imaginary, and you have minus root 3 is equal to 2ab. This is not correct. I mean, it's correct, but it's not correct for the question because the question said using De Moivre's theorem. Guys, follow instructions. Follow instructions. Use De Moivre's theorem. All right. I'm just showing you could do this to get your answer, but it's not correct. So in this case, just to continue it for fun, let's make B the subject. From equation 2, B would be minus root 3 over 2a. Then we're going to plug it into the real part. So 1 is equal to a squared minus negative root 3 over 2a squared. So 1 is equal to a squared minus and minus become plus. And this becomes now root 3. When you square it is 3. Sorry. So, and then now 2a, when you square it, is 4a squared. Then we'll multiply through by the denominator. So it becomes 4a squared is equal to, that's 4a to the 4 plus 3. Now I need more space if I'm doing it this way. So I'm just going to go to the blank sheet. Go to my blank document. We have 4a squared equal to 4a to the 4 plus 3. In this case now, I'm just going to put to black. In this case now, let's call a square y. So let y equal a square. You'd be having 4y equal 4y square plus 3. Bring this over. This is now 4y square minus 4y plus 3 is equal to 0. From that, you solve for y. Guys, we don't have time to be factorizing. Let me see. It should be 3 and 1, right? Hope it factorized nice. 3, 1. This looks like, let me see. Signs are the same. Both are negative. If I put 2y here and 2y, will this work? That's 6. No, that won't work. If I put 4, alright. Too much mental work after the summer break, guys. As you can see, I'm recording this. School don't start yet. Not fully back in the groove yet in terms of calculating. Been a long vacation for the summer, so the brain is not up to par as yet. So I'm just gonna solve it using equation. Alright, so 4, B is negative 4, and C is 3. Solving it. There we go. So in that case, solving, I get one answer. One answer is, well, I should be getting real numbers, so something would have went off. This is saying half plus root 2 over 2. Something would have went, so I even made a mistake in this method here. So I'm trying to figure out where the mistake would have been made. Minus when you square it is, why this turn? So you see, guys, I made a mistake doing this method. So this method even likely to give you mistakes. And I'm not editing out anything, alright? I'm not editing out anything. I want us to see these mistakes. So this would have been a negative 3. It's not a big mistake, but that's okay. Maybe now it would be factorized, but I'm still a little hangover from summer, so I won't be factorizing anything. I'm still gonna use the calculator. All I will do is go and replay and change C to negative 3. X, one answer is 3 over 2 and negative a half. So x equals 3 over 2 x equal negative a half. Well, not x, y. Y. Remember, this is y. I said, let's call it y. And y was actually a square. So a square is 3 over 2 and a square is minus a half. This one don't make no sense. That's not valid. I won't use the purple again because it's hurting the eyes. So this is the one we focus on. A square is 3 over 2. Since a we said was a real number, so in that case a is the square root of 3 over 2 and it's plus or minus. A is the square root of 3 over 2. Alright. And once you get a, then now we're able to find b. Because then remember what was b. Let's go back. We get a is the square root. From our calculations here, a worked out to be the square root of 3 over 2. And so b, remember, would be this. And you just put it in your calculator. Your calculator is minus, let me go and compute first, minus root 3 over 2 times a, and a which is square root of 3 over 2, and this would give you b. What did I do? That's 2 times a I'd say in syntax. So minus root 3 over 2a. I don't see I typed anything wrong. Oh, sorry guys, square root there. This is it. And so b is the minus root 2 over 2 when you work it out. Alright, so that gives you b, which is minus root 2 over 2. So either way you do it, this and this, give you the same answer. Because remember, when you get root 3, the square root of 3 over 2, remember when you rationalize it, you'd end up get root 6 over 2. Alright, remember there's a thing called rationalizing. So if you actually put in your calculator, you realize that, see there, the a value we get right here is the same as the root 6 over 2, and then the b values are the same. So guys, this is how they wanted it. Do not do this. Alright, this is an extensive video. I'm just going through very slowly. Alright, now question number 2. It says use integration by parts to evaluate this. I need some water. So using integration by parts to do this, first thing, I like to call my integrals I. So let I equal the integral of sec square x cosec square x dx. And so now we have to use our substitution. Remember by parts, remember the integral of, let me write it out up here. Remember the integral of u dv is equal to uv minus the integral of v du. Please remember this, the integral of u dv is equal to uv minus the integral of v du. Please remember that, guys, please. So in this case now, we're going to put this as u. U is sec square x, and so du is equal to cosec square x. Now, one thing I remember is when I differentiate tan, I get sec square. So likewise, what relates to tan? Cot. So that means when I this part right here, this is dv by the way. I know I'm not writing so pretty. So look what I'm saying. When I differentiate tan, I get sec square, right? So that means when I integrate cosec, I must get minus cot x. Now, if you don't remember it, because trust me, even as a teacher, sometimes it's difficult to remember these things. So look what I'm going to do. I'm going to actually show you. Look what I'm saying. If v was negative cot x, dv by dx. Remember, cot is cos x over sine x. I'm going to even make it a little bit bigger. Change it to plus 3. Look what I'm saying. So in this case, right, differentiating using quotient rule, you start with the bottom times the derivative of the top. When you differentiate negative cos, you get positive sine. Start with the bottom times the derivative of the top minus the top times the derivative of the bottom. When you differentiate sine, you get cos x over the bottom square sine square x. In this case now, right, so all I'm doing is I'm differentiating cot. And when I differentiate cot, I should get back cos x squared. Let's see, sine times sine is sine squared, negative and negative is positive. So this in the numerator is sine square x plus cos square x, which we know is 1. So in this case, we're getting 1 over sine square x, which is 1 over sine square is what? Cos x squared. So notice what I just did. I just proved to you when you differentiate cos, when you differentiate cot, you get cos x squared. So when you integrate cos x squared, you're going to get back cot. That's what I just did, all right? So you don't need to memorize it. You can always like do it on the side of the paper. Do it over here, right? This over here, do it over there. So if you don't remember, that's fine. No need to differentiate sec square. Now to differentiate sec square, let me change it back here. Remember, this, you're really seeing this as, let me change it from writing the sec square like this. I want you to see this as sec x all square. See this as sec x all square. Why did it do that? See this as sec x all square. By doing that, sec square x is this indeed. Carry down the power, you subtract 1 from the power, but then you multiply by the derivative of what's in the bracket. When you differentiate sec, you get sec x tan x. I need more space. I'm so sorry. I had to erase again, man. We got to erase again because we need more space. So we carry down the power, we subtract 1 from the power, then we multiply by the derivative of sec x, which is sec x tan x. Now again, I am not expecting you to remember when you differentiate sec x, it gives you sec x tan x. It is in the text and it is there for you to know. Alright, it is there for you to know. But if you cannot remember again, you can always do this on the side of your paper. I don't remember how to differentiate sec, so I call y sec x. How do I differentiate sec? Sec is 1 over cos x. And so this is cos x to the minus 1. I want to say that. Well, let's not write this. Let's just use 1 over cos x, alright? So in this case now, I'm going to differentiate this dy dx. Hey, start with the bottom, cos x, times the derivative of the top. When you differentiate 1, you get 0, minus the top, times the derivative of the bottom, minus sine x, over the bottom square. When you square cos, you get cos square. Minus and minus become plus, so now we get sine x over cos square x. But remember, this can be rewritten now as sine x over cos x multiplied by 1 over cos x. Cos square is cos x times cos x. Then sine over cos is tan x. And 1 over cos x is sec x. So, you realize when you differentiate sec, you get tan x sec x. Or sec x tan x. So again, you don't need to remember this. But if you do remember it, kudos to you. In this case now, what we're going to have is du is equal to 2 sec square x tan x. Alright, when I simplify. Now using the Eilide formula, remember it's uv. So now we have I is equal to uv minus the integral of v du. So in this case it is now uv, so it is now sec square x times negative cot x. So I just put the negative at the front. minus the integral of v du. Now v, remember cot is cos x over sine x. Also this negative and the negative in the formula will let this become positive. I hope everyone is following there. In this case now I'm going to put 2 sec square x tan x cot x. It was a negative cot x, but the negative and the negative let it become positive. Now this right here, it looks difficult, but it's very easy. So in this case, now what we're gonna have, I don't like when I see second cut. So I'm gonna put everything in terms of cos and sine and see. In this case, I notice I can rewrite this as minus sec square is 1 over cos square x times, I know cot is cos x over sine x. That's the first part. Plus the integral of 2 sec square x, I won't trouble the sec x for a reason, times tan x. Then I remember cot x is 1 over tan x. Cot is 1 over tan, alright? Why did I do that? I did that because the cos x in the numerator cancel out one of the cos from the denominator here. Then tan x cancel this tan x. So in that case now what we have is minus 1 over cos x sine x plus the integral of 2 sec square x dx. Now when you integrate sec, when you integrate sec square you get tan, because when you differentiate tan you get sec square. So that's integration by recognition now. And also look what I can do. I can add a 2 to the denominator and put times 2 in the numerator, because 2 over 2 is really 1. I hope everybody is following. Alright, so I put 2 over 2. These can cancel each other, because 1 times 2 is 2. But when I say 2 cos x sine x in the denominator, this is sine 2x. That's the identity for sine 2x. So in other words, this part is really negative 2 now over sine 2x. Right? Plus, as we said, this part now integrate sec square. We get tan x plus c. And then now we can rewrite it further to say this is negative 2 cosec 2x plus 2 tan x plus c. That's it, we'll finish. Easy. So that was a final answer. This is a good question, right? That's it. Integrate sec square cos x square. That's what you get. Easy. Alright. Now this part says we need to evaluate this. Now before I even do this question, what I would do is I would check the answer I'm supposed to get in the calculator, and then I'm going to work towards that. Alright, so I like to know that my answer is correct. I don't want to make any mistake. I take my time and know what's the answer I'm supposed to get. Guys, nothing is wrong. You have the calculator, make good use of it. Alright, so I know this is what we're integrating. Just like to bracket it. Don't confuse the calculator. So we're supposed to get 10.95. So now I'm going to work towards getting 10.95. So I know the answer. Before I even do the question, I know the answer is 10.95. So that's my aim. So in this case now, first thing I'm going to do is I'm going to say, okay, what am I saying again? Yeah, I need to break up in partial fractions. Alright, so the first thing we're supposed to do is break this up in partial fractions. The first, we have 3x over x squared minus 4x plus 5. Can I factorize this? Signs are the first thing, check out the discriminant. B squared minus 4 times a times c. No, that can't be factorized. Since it can't be factorized, we're good to go. And also, alright, let's see. Oh, so, but if I do that, that won't be of any help. Okay, fair enough. So guys, this question is looking, it's looking good because first thing I notice is that if we do a U substitution, all right, I'm just going to start out by U. There are many ways to do it, all right? It's just the first one that's popping out to me. All right, is I notice if we do a U substitution and let U be equal to x squared minus 4x plus 5, all right, if we do that as our U substitution, then du is going to be 2x dx. Well, let me not forget the minus 4. I also need a minus 4 dx. Alright, that would become du. So what else do I need? Also, I would have to change my upper limit. I would have to change my upper limit to plug in. When x is 5, I plug 5 here. So 5 squared minus 4 times 5 plus 5. That is 5 squared is 25. 25 plus 5. 25 plus 5 is 30. 30 minus 20 is 10. Then my lower limit is going to be plug in the 2. 2 squared is 4 minus 4 times 2 plus 5. This is now, it's a headache. Too much calculation fresh off the summer. Alright, so I'm going to use a calculator. That's now 1. Now, what else changes? Now, since I'm doing substitution, right? So, look what we're saying now. So, I'm going to space it. Oh, we have a lot of space. So, no worries. So I'm saying now, let's call it I, which is the integral from 2 to 5 of 3x over x squared minus 4x plus 5 dx. In order for me to get this minus 4, I'm going to put a minus 4 in the numerator and put a plus 4. I hope you saw that. Guys, minus 4 and plus 4 cancel each other. Minus 4 and plus 4 do what? Cancel each other, so I'm not doing anything wrong. So what I am saying then is pretty much I'm rewriting the integral as the integral from 2 to 5 of, I'm changing it to, and look what I'm further gonna do. Alright, so remember there's multiple ways to do this question. I already started this difficult route which I shouldn't have taken. I'm gonna show you another method as well, but I already started this route. Alright, I would have probably complete the square now to make it. Yeah, completing the square is easier. Matter of fact, I'm not gonna, guys, I'm gonna actually show you this way, but I think completing the square is way easier. Alright, so as I say, I'm gonna go back to this way and I'm gonna do it this way since I already started it. But just to take a U spin, I'm gonna do it the easier way, which is completing the square. Alright, so whichever way pops out to you first, that's fine. So this was integrating from 2 to 5 of 3x over x squared minus 4x plus 5 dx. This way is way shorter, so I'm going to do completing the square, then go back to my substitution method. So in this case, completing the square in the denominator becomes the integral. I need this to be a little bigger, 3. In this case, it becomes 3x over completing the square, x minus half of this is 2, close the bracket, square. Then we subtract 2 squared plus 5 dx. So in that case, it becomes the integral of, this is now 3x over x minus 2 all square. And this is, let me see, minus 2 when you square it, that's minus 4 plus 5 is plus 1. So why did I do it like this? Because by doing it like this now, this allows us to look at what we'll be working with. But truth be told, this is, whoa, guys, I'm telling you the honest truth, I'm winging it. I'm winging it. Rusty. So, now, as I said, this is a difficult question. I didn't really look at the unit 2 paper in thorough depth, but now when I think about it, this is a good question. So, let's see how we're going to tackle it, because both ways look difficult. So I'm going to take it this way here with the substitution. All right, so I is equal to Separating it, I have the integral from 2 to 5 of 3x, and I'm changing 3x to 2x minus 4. Don't worry guys, you're going to see what I did here. X squared minus 4x plus 5 dx. Alright. And then now I have plus the integral from 2 to 5 of, this was 3x and I have 2x here, so I need back a x and a plus 4 over x squared minus 4x plus 5. Don't worry, you'll see what I did soon enough, okay? You'll see what I did soon enough. It's perfectly fine. So from that standpoint, now I can integrate this part, because this part now I can use u substitution. So now this part I have equal the upper limit for this part. Now I'm changing that part 1 to 10. Alright, change that part 1 to 10, and then right here now 2x minus 4, that is my du. So this part is du, so this is now 1 over u du plus. Now I need to figure out how am I going to integrate this part now. How am I going to integrate this part? 2 to 5 of x plus 4 over this. Alright, so I'm just going to go further and separate, because I always feel comfy just separating 2 to 5 of x over x squared minus 4x plus 5 dx plus the integral of 4 over x squared minus 4x plus 5. Alright, remember the aim we should get 10.95. This part now, obvious, integrate 1 over u du. So when you put in, this is become, integrate 1 over u is ln u, so that's ln 10 minus ln 1, and ln 10 minus ln 1, that's okay. Plus now this part, we need to integrate this part. Now, let's see. Now we're integrating x over x squared minus 4x plus 5. What's the technique? If we, let me see if the substitution can be upheld here. X squared minus 4x plus 5. If we put that as u, du is 2x minus 4. We would have a x here. I want to get out all the x's. So I see, this is not conventional, guys. I don't think there's, of course, an easier way. I possibly should have done this paper for us right after the Unit 2 exam instead of waiting so late. There's always an easier approach. So here you see, this is a lengthy approach that I am taking. So what I'm saying here now is, if I put times 2 over 2, right? So this is really 2x plus 8. Alright, that's really 2x plus 8. So I change this now to 2x, and I have a half out here. So I have 2x plus 8 over x squared minus 4x plus 5 dx. And I can always change my plus 8. What I want is just a number, right? So can always change my plus 8. I need a negative 4, so negative 4 plus 12, because 12 minus 4 is 8. Guys, I know it is not so nice, right? I'm doing it a harder way. I'm gonna show you an easier way. Maybe later on, alright? Later on I do a separate video on just this question. Easier ways, alright? So in this case now, why did I do that? That way I can apply back my u substitution again, because now I generate this part. Now I can separate as half 2 to 5 2x minus 4 over x squared minus 4x plus 5 plus half the integral of, I'd be left back with the plus 12. Now it's in a form where it is very easy, guys. Now it's in a form where it's very easy. Alright, yes, 9 marks. No wonder, it's a nice question. Once it's in this form now, I can This part is just log 10 plus this part now is half. We can apply our u substitution and it becomes, remember this part would now be du and the denominator is u, so it's a half, and we have now the integral from 1 to 10 now of this part is what? This part is our what did we say again? This part's our du. So we have our du and this denominator is u. Plus now we just have half the integral from 2 to 5 of 12 over x squared minus 4x plus 5. Now it is easy, guys. So bringing up here, alright, bringing it up here. Well, I can still finish down here. So continuing now, we have log 10 plus, this would give us half of log 10. Alright, and then now the only thing we're working out now is half the integral from 2 to 5 of 12 over x squared minus 4x plus 5. Guys, this was a tough question, alright? This is a tough question. I can say this is a good question. So now at this stage now, we can complete the square. And why am I completing the square? From the start, I was completing the square because we know that the integral of a over a squared plus x squared dx, that's equal to what? Tan inverse x over a, right? This is the form that whenever you need something to look in this form, you can always take that approach. So we need it in the form where we can use tan inverse now. That's our whole aim. The aim is now to put this in a form where we can use tan inverse, right? So in that case now we need to just work out this. So we're going to break away from this part for now. We're going to break away from this part. We're good with this part. So now we're going to focus on this part, right? Let's call it J. So right here, let's call that J. That's the part we're focusing on. And so let J be equal to half the integral from 2 to 5 of 12 over x squared minus 4x plus 5 dx, completing the square, so j is now half the integral 2 to 5 of 12 over, this is now x minus 2 square plus 1 dx. Oof. So now remember, we need it in the form. This right here is very helpful now, right? This right here, very helpful. We need it in the form so we can get tan inverse, right? So in this case now, we know if this was 1, it would be tan inverse x over 2. But because it's a 12, we can take out the 12. This is really 12 over 2 integral from 2 to 5 of 1 over x minus 2 squared plus 1 dx. In this case, that part is working out to be 6. And when you integrate this, you get tan inverse x minus 2, and a is 1 in this case, so it's not even doing anything. So it's tan inverse x minus 2, all right, and we're going from 2 to 5. So now we plug in, this is now 6, tan inverse of 5 minus 2 is 3 minus 6, tan inverse of 2 minus 2 is 0, so tan inverse 0. So in other words, our final answer is just log 10 plus half log 10 plus 6 tan inverse of 3. That's our final answer. And you now put it in a calculator and we're hoping we'll get 10.95. Because remember, we had got 10.95. So log 10 plus half log 10 plus 6 tan inverse of 3. And we got our 10.95. Guys, I'm not gonna lie to you, this was a very, very, very difficult question. This was a very, very, very difficult question. Alright, so We got our answer though, and we're okay with it. So no problem. Alright. That was all of that. Of course, there's another way to do it, guys, but as I said, it's September 2. And just come off a long, extensive summer break, just as you are. Had a nice vacation. And so I'm a little rusty. I possibly should have done this video right after the exam, but that's how it is sometimes. This one now, it says determine the integral of x plus 1 over x cubed minus 9x. So we're going to have some fun with this one. I like to call my integrals I. We're integrating x plus 1 over x cubed minus 9x dx. So the first thing we're going to do is partial fraction. Let's do the partial fraction here. So x plus 1 over x cubed minus 9x. That's really x plus 1 over x in bracket x squared minus 9, which is really x plus 1 over x times, this is a difference of 2 squared, x minus 3 times x plus 3. So it works out super easy. It's going to be a over x plus b over x minus 3 plus c over x plus 3. So now we can find the LCM. The LCM, which we know is x times x minus 3 times x plus 3. Alright, that's the LCM. And all of that will give us, of course, x plus 1. So in that case now, x into this, that leaves a times x squared minus 9. Remember, x into this leaves these two, but when you multiply them, you get x squared minus 9, remember. Plus b times x minus 3 into this, x minus 3 cancel, leave x times x plus 3. Then plus c times x minus 3 now, because the plus 3 is cancelled. So equating numerators now, so equate numerator. Equating numerator, we have x plus 1 is equal to a in bracket x squared minus 9 plus bx times x plus 3 plus cx times x minus 3. And now, man, this is a lot of work. X plus 1 equal to ax squared minus 9a plus bx squared plus 3bx plus cx squared minus 3cx. Now first thing, let's equate x squared. So from our x squared terms, we notice there's none over here. So 0 equal, there's a x squared, there's a x squared, there's a x squared. So 0 equal a plus b plus c. Then now let's equate our x terms. We notice we have 1x. So equating our x terms, we have 1 is equal to, these are the x terms. So we have 3b minus 3c. Then from our constants, how many constants we have? This is 1. We have minus 9a. No more constants? 1. That's the only constant there, which makes it easier for us. So from our constants, we have 1 is equal to negative 9a. So from that, we're able to work out that a is equal to 1 over negative 9. And once we're able to get a, we're then able to evaluate b and c, because now we have two equations. So from the first, so now putting in equation 1, let's call this equation 1, and let's call this equation 2. So we can sub a into equation 1, and so what that gives us now is, bringing it to the other side, we'll have 1 over 9 then is equal to b plus c, and from equation 2 we have 1 is equal to 3b minus 3c. So we can go on to tackle it. I don't like fractions, so I'm going to multiply this equation by 9. If I multiply it by 9, I have 1 equal 9b plus 9c, and then if I multiply this equation by 3, I have 3 is equal to 9b minus 9c. Then I can add the two equations, and by adding them 1 plus 3 I get 4 is equal to 9b plus 9b is 18b. And I notice the c's cancel. Divide by 18, so b is equal to 4 over 18, which is 2 over 9. And in that case now, I can now go ahead and find c. Let me zoom out so I can go to the next page. So now, remember, 1 is equal to 9b plus 9c, which means that 1 is equal to 9 times b, remember, was 2 over 9 plus 9c. This 9 cancel this 9, so 1 is equal to 2 plus 9c. Bring over the 2, that becomes negative 1 is equal to 9c, and so c is equal to negative 1 over 9. From that now, I can write down my answer and tell them, okay, and so the integral of x plus 1 over x cubed minus 9x, it's equal to, remember it was a over x, but a is negative 1 over 9. So it's negative 1 over 9x plus, it's then b over x minus 3. B is 2 over 9. So it's 2 over 9 times x minus 3 plus c, and c is minus 1 over 9 times x plus 3. That's your answer. Easy, easy, easy. Nice. So I can tell you, guys, I'm not going to hide it. This pure maths paper so far is looking like a nice paper, a nice workout. Alright, so that's that right there. Onto module 2. Module 2, it starts by asking us to determine the coefficient of x to the 4 in the binomial expansion of this. Now, first thing, I notice that is 1 minus 2x to the first power, and it's being multiplied by 1 plus 3x square. And when I bring it up to the numerator, it's to the minus 2. Alright? So that's what we have. I need to determine the coefficient of x to the fourth power. Alright, so this is what we're gonna have to do. Now, in this case now, as you can see, once it's negative powers, once you're dealing with negative powers, then we know which one we're gonna have to use. We're gonna have to use 1 plus nx. Remember this one? 1 plus nx, or a plus x to the n. This is what I mean. 1 plus x to the n. We need to remember this is the 1 plus nx plus n times n minus 1 x squared plus n times n minus 1 times n minus 2 x cubed. Remember this is over 2 factorial over 3 factorial, and it continues. That's the one. The next one would give us the x to the 4 term. So anytime you would see a negative power, this is the formula you're gonna have to use, okay? That's the formula you're gonna have to use. But guys, it is very, very easy. So ignore the 1 minus 2x. You're focusing on this part. You're gonna say now 1 plus 3x to the negative 2. We're gonna tell them this is equal to, in this case, notice the x is 3 and n is negative 2. So it's 1 plus nx, n is negative 2, x is 3x, plus n is what? Negative 2 times n minus 1, negative 3. Then we have our x squared. Our x squared is 3x being squared over what? 2 plus n minus n minus 1, so n negative 2 times negative 3 times n minus 2 now is negative 4 x cube, which is now 3x cube over 3 factorial, which is 6. So now we just need to simplify this. So we're getting 1 plus 3x, the negative 2 is equal to 1. This is now minus 6x. And guys, so much computation is not so good for me right now. I'm going to use the calculator. As I said, fresh off the holiday, guys. Fresh off the holiday. It's not in this mode as yet. So I'm using the calculator. So plus 20. What did I get a while ago? All of this simplified to be 27. So 27 x squared over 2. Then this part now plus, over here negative, and negative is positive, and negative, so this is going to be a negative 1 now, for sure. And take out the calculator, negative 2 times negative 3 times negative 4 times 3 being cubed over 6. Negative 108 over 6. And that's x cubed. So finally, just to write my last, well, not really last answer, but my simplified expression here. This is 27 over 2x squared. 108 over 6, I believe that's 18, so minus 18x cubed. Now we need the coefficient of x to the 4. Now guys, this is where it gets really fun. Notice we need to multiply it now by what? 1 minus x. So what we're going to tell them is, so now 1 minus 2x times 1 plus 3x to the minus 2 is equal to, that does mean this answer we have right here, we're going to multiply it by 1 minus 2x. So 1 minus 2x, we're multiplying it by 1 minus 6x minus 27 over 2x squared minus 18x cubed. It is that simple. And so now, we just need x to the 4. So I notice if I multiply 1 times all of this, that won't give me any x to the 4. This times this one. So the only one that will give us x to the 4 is if we multiply these two. So in that case, we can say, so minus 2x times minus 18x cubed equal 36x to the 4. So the coefficient of x to the 4 is 36. Easy, easy, easy. That's it, guys. It wasn't a bad question, but it was tricky. I can say it was tricky. All right. This one now, part B. Show that if the series that converges, then that's its sum to infinity. If the series converges, so first thing we have to take in, the big fact is that if it converges. So if the series converge, then we know that the sum to infinity is a over 1 minus r. So in that case, now we need to find what r is. So r, which is the common ratio, so the common ratio is equal to the second term divided by the first term, which is 7 over 3x minus 5 divided by 1, which is 7 over 3x minus 5. And then now, for first term, a is 1. And a is 1. So in that case now, the sum to infinity is a over 1 minus 7 over 3x minus 5. In that case, this is 1 over, anywhere you see 1, you can write it as one fraction. 1 by itself is 3x minus 5 over 3x minus 5. And then we're subtracting 7 over 3x minus 5. This is 1 over 3x minus 5 is minus 12 over 3x minus 5. And now look at that, it finished. Now when you have a fraction, or when you have something being divided by a fraction, you change it from division to multiplication and then you reciprocate. In this case, it becomes 3x minus 5 over 3x minus 12. Done. How many marks for that? Has to be 5. Can't be more than 5. 8 marks for that, and we didn't do anything. We take it. Sum to infinity is what? If the series converge and the sum to infinity. And if you want to just add further information, you can write provided the common ratio is between 1 and minus 1. But it has to be since they say it converges anyway. Right? So that's what we have. Easy. The next part now. It says use mathematical induction to prove this. So to use mathematical induction, first thing, show that the nth derivative of this is this. Okay, no problem. So first, let's start with when n equal 1. So for n equal 1, the left-hand side is going to be the first derivative of e to the x sine x. Alright? So in that case now, when we differentiate e to the x sine x, we use product rule. We keep the first times the derivative of the second, or differentiate sine, we get cos, plus keep the second times the derivative of the first. So in that case, if we factor out e to the x, this is e to the x in bracket sine x plus cos x. That's for n equal 1. Now your right hand side is going to be, when n is 1, when we put n is 1 there, you get 2 to the 1 over 2, that's 1 over 2, e to the x in bracket sine x in bracket x plus, this is n is 1, that's pi over 4, this is your right hand side. Now this is really square root of 2, so that's square root 2 e to the x sine, oh it's not sine x, it's sine in bracket. Alright, so remember we can expand sine. So expand sine now, so I'm going to take off this. I can expand sine using the formula. How the formula go again? Sine, cos, sine. I think that's how it is. Let me write it down. Sine A plus B is sine A cos B plus cos A sine B. That's the formula, right? So in that case, our A is x, this is our A, and this is our B, right? So in that case, now I'm going to expand it. So expanding it is sine x cos pi over 4 plus cos x sine pi over 4. Now, this works out to be cos pi over 4. Put that in the calculator. I know cos pi over 4. I don't know why I'm using the calculator. It should be cos 45 is root 2 over 2. But just for safety, I'm using the calculator. Pi over 4. I know it is root 2 over 2. Yeah? So in that case now, our right hand side is working out to be root 2 e to the x times, this is now cos pi over 4, as I say, is root 2 over 2 sine x plus, this is now root 2 over 2 cos x. And in this case now, root 2 times root 2, this root 2 cancel. Well, root 2 times root 2 is 2. Root 2 times root 2 is 2. So this becomes 2 over 2 sine x. So it can work out to be 2 over 2 e to the x sine x plus, this times this becomes 2 over 2 e to the x cos x. The 2 over 2 is 1, so it still works out to be e to the x, and factor out we're leave with sine x plus cos x. So we're good. So it worked out to be the same, guys. So for n equal 1, it is true. So n equal 1 is true. So now we're going to assume n equal k is true. So for n equal k, we have our statement is dk over dxk of e to the x sine x. It's equal to, where n is, we'll put k, that's 2 to the k over 2 sine in bracket x plus k pi over 4. And we assume that this is true. So we assume true. Now, first thing I like to do is write down what we're required to prove. RTP, write down what you're required to prove. Before you do the proof, write down what you're required to prove. So I like to write this down. We're required to prove, so for n equal k plus 1, we're supposed to get d to the k plus 1 over dxk plus 1 of e to the x sine x. We're supposed to get 2 to the k plus 1 over 2 sine in bracket x plus k plus 1 pi over 4. That's what we're required to prove. Okay, so let's work towards that. So now we can state for n equal to k plus 1, right? Let's see if there's anything that we can use to help us. Oh, here it is. This is the fact that we need to use. So this is the one we're going to use in our question. That d to the k plus 1 of dx plus k plus 1 of the function of x is the derivative of the kth derivative. So we're going to start by saying for n equal k plus 1, alright, we have dk plus 1 of dx to the k plus 1 of e to the x sine x. We're saying that this is equal to derivative of, it's a derivative of what? They just told us that it's a derivative of d to the k of d to the xk of e to the x sine x. It's very easy, guys. Now, we had assumed that this was true. So this was our assumption. Our assumption was this is the answer. This is dk of dx to the k, right? So we assume that this right here, so we're going to basically work out the derivative now of, this is 2 to the, we said that the assumption was 2 to the k over 2, 2 to the k over 2. There's no e in it? Oh, I left out the e to the x, because I know then this would be a little off, yeah. So 2 to the k over 2, e to the x, 2 to the k over 2, e to the x sine x plus k pi over 4. And then now we need to show that when we differentiate it, we should get this right here. So guys, this is so easy. Like, only thing though is I would say this is very tedious. It's a long process, but it's very easy. So to differentiate it, we use product rule. Keep the first. So 2 to the k over 2 e to the x. Keep the first times the derivative of the second. When we differentiate sine, we get cos. We get, why this keep disappearing, man? Sorry guys, the pen I keep writing. Look at that, a rope, and all know it don't erase. Come on, man. Alright, so it's just freezing a bit, guys. Bear with me. So we keep the first times the derivative of the second. When we differentiate sine, we're going to get cos in bracket x plus k pi over 4. Right, that is it. When you differentiate sine, you get cos plus, keep the second now. So we keep our sine in bracket x plus k pi over 4 times the derivative of the first. Now when you differentiate e to the x, you always get back e to the x, but there's a constant, so you put back a constant 2k over 2 e to the x. But now we realize what? Wait a second. This is in the form what? This is in the form what? This is in the form, I want to explain it right. This is in the form, this is in the form of compo, this is in the form of the compound angle for sine. I don't know why it's not coming out. Alright, this is in the form of the compound angle for sine. So again, we need to remember the formula for sine A plus B. It is equal to sine A cos B plus cos A sine B. So in this case now, you notice if we're supposed to factor out 2 to the, if we factor out 2k over 2 e to the x, alright, notice we're left back in here in this bracket with cos x plus k pi over 4 plus sine x plus k pi over 4. But then you're wondering how I get this into this. It stems from what we basically did earlier. Remember what we did earlier right here? We had to multiply in the root 2. So somewhere we know that, wait a second, in order to get this right here, sorry, not scrolling so far, we know that we need to have something before the cos, but the something we need to have before the cos is sine of something. And we know that before we have the sine here, we need to have the cos of something, and they should be the same thing, right? They should be the same thing that somehow allows us to cancel and get that this will work out to be this. And I'm going to actually show it. All right, need to work out to be this. 2 to the k plus 1 of this. Now, this is what you can do, all right? Guys, I'm showing you the tricks and the traits. This right here is really, and I'm going to erase it off. All right, this is what we're required to prove. This should be a final answer, but we reach a point and we're like, how are we going to get to that final answer? All right, that's why I like to write required to prove. This is really sine right here. This is really x plus right here. This is k plus 1 pi over 4. So the formula says it is sine A cos B. So that's cos k plus 1 over 4 pi, right? So, and then it is cos A. Let me write it out. So this right here, look what I'm saying. This is sine A cos B, which is k plus 1 pi over 4 plus cos A sine B, k plus 1 over 4 pi. Right? So that's what we have. So I'm saying, how are we going to show this from what we have right here? Right? So we have right here, as you can see, we have cos x plus pi over 4, sine x plus pi over 4, and it is supposed to be what? It's supposed to just be the sine. Alright? That's all. So it's supposed to just have 2 to the k plus 1 e to the x sine x plus k plus 1 pi over 4. So basically, alright, this part right here, when we expand it, that's what you would get. This right here. And then down here, we just need to simplify this part to show that this part work out to be that up there. Alright, so it is easier said than done. Now we're gonna actually have to show it. Alright, so let's look at how we can get creative without doing too much work. At the end of the day, we want to simplify the amount of work we have to do Because if we expand it, let's see if expansion would help. At the end of the day, we're trying to look for the easiest route. If I expand this, I would have cos minus sine. Expanding this part, I have sine, cos, sine. Then I'm going to need to multiply in. But what I need is this to become, oh, so that also works. So see there, guys, just actually play around with it. This would work as well. So what we're trying to generate here, so let's see, this is 2 to the k over 2 e to the x in bracket. This become cos, so cos x, cos, come on, stop disappearing, cos k pi over 4. So it is cos minus sine. Then this part now is plus. This part is now sine x. Stop disappearing, please. Cos. Can you please stop disappearing? Stop disappearing. So guys, I don't know why, but the keyboard is disappearing when I write. Alright, and then it is sine A cos B plus cos A sine B. Alright, so now we have all of that. Alright, now we have all of this. Now, this works out to be 2 to the k over 2 e to the x in bracket. Now, you're wondering how we're going to work out what this value is, right? How are we going to find out what that value is? But this is how we can get an idea. We notice that if k was 1, it would be 1 pi. What if k was 2? 0. What if k was 3? Negative now. What if k was 4? 0? Negative 1. What if k was 5? Negative. What if k was 6? What if k was 7? What if k was 8? What if k is 9? What am I saying? Alright, so we notice, alright, right here, when we're evaluating this part is a tricky part now. Alright, cos, sine, cos. That's really not to our benefit. What we're trying to do is show that, look what I'm saying, 2 to the k plus 1, that part is 2 to the k times 2. We're really trying to show that um, we should get a times 2 somewhere here. But actually I'm not seeing it. It's a good question. Why it's not so evident? Um, this line. Alright, so as we can see, this e to the x right here, wham bam, that's out. We now need to get 2 to the k plus 1 e to the x sine of all of that. Now, we're not going to do any gimmicks. Did they give us any other hint? They may need to give us one more hint, guys, because otherwise this is going to take us a long time to do. We don't have time to be doing a trigonometric proof. This will take too long. They need to give us another hint. They have to. Alright, they have to give us another hint. Alright, so maybe I missed something. I'm going to go back to the rules. They have to give you another hint at this point. Alright, they have to give you another hint. Because, again, the exam is what, 2.5 hours long. I may take a little more than 2.5 hours because I'm working as slow as possible and trying to be as detailed. And also because the computer is doing stuff like this, freezing. See, it's frozen. It's gonna get better soon, but it's frozen for this point, so Still frozen. We're just waiting. It's gonna get better, guys. It's gonna get better. Alright, now it is better. So they had to give us another hint. Using the fact that here is the hint. Using the fact I know they had to give us a hint, guys. I don't know why I didn't see this hint. They said using the fact that sin x plus cos x is this. Alright, so using this hint. Use this hint. Let me change it to a different color. The hint I want to highlight. They were gonna utilize that fact. So the hint they gave us was this. Sin x plus cos x is this. Bear this in mind. So I'm just gonna write this hint down on the next page. Sin x plus cos x is this. Why is that so useful? So I'm gonna write, recall sin x plus cos x is equal to root 2 what? Root 2 sin x plus pi over 4. Why is that useful, guys? That's useful now because if we replace x with x plus k pi over 4, look what I'm saying. Replace now all of this gonna go where x is. All of this x plus k pi over 4. If we replace all of that right there, then what we're saying is sine in bracket x plus k pi over 4 plus cos x plus k pi over 4 is equal to root 2 sine in bracket where x is, we put what? X plus k pi over 4 plus, this is now what? Or pi over 4. Did you see what I do? Where x is, only thing I did was everywhere x is, I put x plus k pi over 4. So everywhere x is, we put x plus k pi over 4. So in that case now, our final answer is going to be equal to, so just to draw my arrow, continuing down here, it's equal to 2 to the k over 2 e to the x in bracket. That become root 2 sine in bracket x plus k pi over 4 plus pi over 4, one denominator over 4. And so I can rewrite this as factor out pi. So I have now my x plus k plus 1 pi over 4. Alright. Now I have all of that because remember everywhere x is, I put x plus k pi where x is. Follow what I'm saying? Where x is, I put x plus k pi over 4. And remember, just to not confuse you, this is what it is. Alright, so now that I get this, now I'm finished. Because now I'm going to tell them root 2 times 2 to the k over 2 is really 2 to the k plus 1 over 2. Alright? Because this is half and k over 2 plus half is k plus 1 over 2 e to the x times the sine of x plus k plus 1 over 4, all of that times pi. So now we're finished. Alright, and so now we can conclude, therefore n equal k plus 1 is true. And so we can conclude thus, by principles of mathematical induction, we can tell them the statement above is true. Alright, that completes this question. Number 4. Guys, we're working so slow because I need to go faster, right? So now this part says, use intermediate value theorem to prove that it has a root on this interval. So if it have a root on that interval, then that means first thing f of minus 2, I'm just calling this function f, is going to be minus 2 to the 5th power minus 2 times minus 2 cubed plus minus 2 square plus 2. One should be greater than 0 and one should be less than 0. That's what we know. That's IMVT. And I'm going to put both in the calculator. I'm just working this out real quick. Alright. So working it out real quick. Minus 2 raised to the 5th. Minus 2 in bracket. Minus 2 cube. Plus minus 2 square plus 2. This is what you're getting. Negative 10. Which is less than 0. Then we need to change it now to 1.5. We change it to negative 1.5. Change this to negative 1.5. Change this to negative 1.5. And that one is 3.40625, which is greater than 0. So if you were to give them a sketch of what we're talking about, the root being this is negative 2 and this is negative 1.5, we notice that the y values we're getting, one is negative 10, which is right here, and then negative 1 point, that is 3 point something, which is right here. If you show them the sketch, there's a root in there. So you can tell them by IMVT, since f of negative 2 is less than 0 and f of negative 1.5 is greater than 0, there exists a root on the interval negative 2 to negative 1.5. That finishes it. Next part. Hence, using two iterations of the Newton-Raphson method with initial root as negative 1.5, we need to calculate the new root. The first thing we have to remember is Newton-Raphson method, so xn plus 1 is xn minus f of xn over f prime of xn. So first thing, f of x to the 5th minus 2x cubed plus x squared plus 2. F prime of x is going to be 5x to the 4 minus, all we're doing is differentiating 6x squared plus 2x. Now, we need to plug in negative 1.5. So f of negative 1.5, initially we had worked that out to be 3.40625. Right, it's right here in the calculator. And then finally, all right, let me close this. And then finally, right here, all right, and then right here now, the derivative, we need to put in, I can't bother work it out so much, man. That's a lot. I'm just going to put it in the calculator, guys. Please just bear with me. I'm just using the calculator, all right? The derivative, 5 times negative 1.5 raised to the 4th power. Just using the calculator, all right? We're using the calculator. So 5 times negative 1.5, and this is raised to the 4th power, minus 6 times negative 1.5, and this is raised to the 2nd power. And the next thing, when we differentiate it, was plus 2 times negative 1.5. Trying to save time here. So we'll get 8.8125. So this is 8.8125. So using Newton-Raphson, the first time, we're saying x2, our second approximation is negative 1.5 minus Computer, stop doing this for me, please, and write better. Guys, I don't know, the computer sometimes does this. So minus 3.40625 over 8.8125 equal. Now I put that in the calculator. Putting it in the calculator, negative 1.5 minus fraction button 3.40625 over 8.8125. I'll put that in the calculator and we get this negative 1.89. So this is now negative 1.89. When we get negative 1.89, we need a third approximation of the root. So first thing we need to check out, we need to evaluate now f of negative 1.89. Now I'm just going to put it back in the original formula. Remember the original formula, x to the fifth, so negative 1.89 raised to the fifth power, then minus 2 times negative 1.89, that's raised to the third power, then plus negative 1.89 raised to the second power, then we add 2. This is negative 5.04, which is less than 0. So where does the root lie? So this is negative 1.8, negative 1.88, giving us the negative 5 point something. So that means the root now lies between negative 1.89 and negative 1.50. Even though that don't matter, right? That's if you're using bisection, but just for the fun of it, I did that. So now, the third approximated root, first we need to now find the derivative of negative 1.89. It's going to be, let's differentiate it and plug it in. We already differentiate the function. I'm just going to plug it in, guys. We're trying to save time. 5 times right here, where x to the 4 is, negative 1.89 raised to the 4th power. Then we have minus 6 times. This is negative 1.89 raised to the second power. Then we have plus 2 times negative 1.8. That's what we have. Plug it in and we'll get 38.58 or 38.59. So we'll get 38.59. So in that case now, our third approximated root x3, which we know is x2 minus f of x2 over f prime of x2, which is now f of x2 negative 1.89 minus f of x2, which is negative 5.04 over 38.59, and you plug that in the calculator, fraction button, well, it's not start fraction, but negative 1.89 minus fraction button, negative 5.04 over 38.59, we get negative 1.76. That's negative 1.76. That's our answer. 6 easy marks for that. Alright? That's it. Negative 1.76. Alright, now this part says show that theta n plus 1, which is equal to sine inverse this, is a suitable approximation for the roots of the equation, this right here. So, show that theta n plus 1 equals sine inverse is a suitable approximation. Oh, so basically we need to make theta the subject from this, no problem. So, in this case we have cosec theta is equal to 4 minus half theta squared, but cosec theta is 1 over sine. So that implies we're solving 1 over sine theta equal to 4 minus half theta square. And in this case now, we can multiply through by 2. So if we multiply through the equation by 2, it becomes 2 over sine theta is equal to 8 minus theta square. All right, now we're trying to make this theta the subject. This theta, we're trying to make the subject. Are we? No, the other theta. So in this case, we flip it. So when we flip it, we're saying sine theta over 2 is equal to, by flipping it, so I want to make sure I multiply by through correctly, 2 over this 8. Yeah. So flipping it, right, this becomes 1 over 8 minus theta squared. So now we multiply through by 2 again. So we get sine theta is equal to 2 over 8 minus theta squared. So then we inverse it now. So which implies that theta is equal to sine inverse of 2 over 8 minus theta squared. So thus we can say therefore theta n plus 1 is sine inverse 2 over 8 minus theta squared. Just algebra, guys. That's a grade 9 student could do that. That is just algebra. Now it says using theta 1 as 0, calculate a new estimate for the root correct to 3 decimal place. So we're going to have to use a formula. It's a hence. So using theta 1 as 0, so theta 1, that becomes 1 plus 1 is 2. So theta 2 is sine inverse of 2 over 8 minus 0 square, which is sine inverse a quarter. I'll put that in the calculator. Keep a calculator in. They want degrees or radians. They didn't say, so it's radians. Sine inverse a quarter, 3 decimal place, 0.25252, so 0.25268. That's theta 2. Alright, now we're going to have to go again. Theta 3 now then is sine inverse 2 over 8 minus theta squared. This was the value for theta. We'll get 0.25268. Now we're going to square it. We'll put that in the calculator. So now we have sine inverse fraction button 2 over 8 minus the result that we just got. The calculator stores it as answer square. Let's see what we get in now. We get 0.2547, 0.254758. Now remember, we need the first 3 decimal place to be the same before we can stop. So we have to go again. Always remember, you stop when the first, let's say 3 decimal place. Look, the first 2 are in common, but we need to get the third decimal to be the same. So now we have sine inverse now 2 over 8 minus 0.254758 square. So now this now we don't need to change anything. Let's press equal. 0.2547. This is now 0.25479. Now notice we got these two to be the same now. So now we can round off and say thus the new estimate. So the new estimate is 0.255. That's your answer to 3 decimal place. Alright, 0.255. Because now we get the first 4 to be in common, but we have to round it up for 3 decimal place. 5 easy marks. Now it says determine the Maclaurin expansion for this. up to, okay, so Maclaurin. First thing before we do the question, write down Maclaurin formula. Maclaurin formula for a function f of x is f of 0 plus f prime of 0 times x plus f double prime of 0 x squared over 2 plus f triple prime of 0 x cubed over 6. That's the formula we're going to use. So first thing, you're going to need to find up to the third derivative. So this is 1 plus x squared cos x. First thing I'm going to do is plug in f of 0. By plugging f of 0, 1 plus 0 is 0. So f of 0 is now, why this keep disappearing, man? Let me do it slow. Good. So now I have 1 multiplied by cosine of 0 is 1. So f of 0 is 1. Now I need f double prime of x. Keep the first, differentiate the second, and I differentiate cos, I get negative sine x plus keep the second cos x times the derivative of the first, and I differentiate 1 plus x squared, I get 2x. And so now I plug in the 0, and I notice sine of 0 is 0, so that is 0 plus cos of 0 is 1. 1 second. Just want to make sure I'm not doing anything wrong here. Cos of 0 is 1, but 2 times 0 is 0. Very good. This is now 0. So now I need the, I did my first derivative. Well, I don't know, I have double derivative here. That should be one derivative. So now my double derivative, that's a lot of work. F double prime now of x is this, we're gonna have to, we already see it as a product here. Keep the first, differentiate the second, and differentiate minus sign, you get negative cos, plus keep the second, negative sine x, times the derivative of the first, which is 2x, plus over here we have to use product rule now. Keep the first times the derivative of the second, plus keep the second, keep the cos, times the derivative of the first, and we'll differentiate 2x, we get 2. So that means f double prime of 0 is, cos of 0 is 1, and so 1 plus 0 times, so this is 1 times cos of 0, that's 1, so negative 1, plus this right here, sine of 0 is 0, 2 times 0 is 0, and then this is now 2 times cos of 0 is 1, so we get 2. So this is now 1 times negative 1 is negative 1 plus 2, which is 1. So far it's working out boring. So we have f of 0 and we have f prime prime. So we need to go one more. One more time, guys. Just one more time. One more time. So going one more time, f prime 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 of x. Use product rule again. Keep the first. Differentiate the second. When I differentiate negative cos x, you'll get sine x. Plus keep the second, which is a negative cos x. Derivative of the first, which is 2x. So differentiate this part. You only need to differentiate this part now. Plus product rule again. Keep the first times the derivative of the second. Plus keep the second times the derivative of the first. And we'll differentiate negative sign, we get minus cos x. Going again. Now we need to differentiate this part. So I put that in blue. Plus, keep the first times the derivative of the second. Differentiate negative sign. We get negative cos. Plus, keep the second, which is a negative sine x. times the derivative of the first, which is 2. Then finally, we need to differentiate 2 cos x. So plus, when we differentiate cos, we get minus sine. So now we can find out the triple derivative now. Plug in 0 here. Sine 0 is 0. Anything times 0 is 0. 2 times 0 is 0. Sine 0 times 2 is 0. 0. 2 times 0 is 0. I find the third derivative. And they want what? 3 terms. Determine. If you get all zeros, it don't make any sense. So you're just going to have to review. Notice all zeros would give us 0x cubed, which makes no sense. So we're going to have to look back through and make sure we didn't make any mistake. So I'm just going to look through thoroughly. Make sure no mistake was made. 1 plus x squared cos x. Keep the first, differentiate the second, plus keep the second, differentiate the first. Good. Plug in the zeros. Sine 0 is 0, so this part is 0. And 2 times 0 is 0, so this is good. Then now, second derivative, making sure no error. Keep first, differentiate the second, plus keep second, differentiate the first, plus keep the first, differentiate the second, plus keep second, differentiate the first. That's good. Plug in the zeros now. That's 1. This is now -1. That's 0. That's 0. That is 2. So that's 1. Very good. Third derivative now. Differentiating second derivative. So keep first, differentiate the second, plus keep the second, then differentiate the first. Very good. Differentiate 1 plus x squared is 2x. Plus in the red part now, keep the first, differentiate the second, plus keep the second, times derivative of the first. When we differentiate sine, we get cos. Plus this part in blue, keep the first, times derivative of the second, differentiate that, we'll get that, plus keep the second, times derivative of the first. Now we differentiate 2 cos x now, we get minus 2 sine x. Good. Then now what do we notice? We'll plug in the zeros now. Sine of 0 is 0, so that's irrelevant. 2 times 0 is 0, irrelevant. This is 0, so that's irrelevant. This is 0, which is irrelevant. This is also 0, which is irrelevant. Alright, so what I'm going to do now, we're going to have to differentiate one more time now. That's a lot of differentiating. Come on, man. CXC, do a little better. Remember that they have 2.5 hour CXC. So now, this is f prime 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 of x. This expression is 1 plus x squared sine x. This 2x minus cos x, and this 2x minus cos x, I'm going to put it as 1 as minus 4x cos x. Is it 4? And then another 2x cos x, so really 6. I'm going to put it as minus 6x cos x. Then this is minus 2 sine x, and another minus 2 and minus 2 make it minus 4x. Minus 4 sine x. Alright, so all I did was group my like term. So I added this, and this, and this. I add those 3. So now I can differentiate it one more time now. F prime 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 of x, keep the first, times the derivative of the second, plus keep the second, times the derivative of the first. Then over here now, minus keep the first, times the derivative of the second, differentiate cos, we get minus sine, plus keep the second, which is now cos x, times the derivative of the first, which is 6. And down here we have, I did the product right, 4 terms, I should be 4, yeah. Then here now, minus, when I differentiate sine, I get cos. Now I can plug in my 0, so my f prime 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 of 0 is, this is now 1 plus 0, and cos 0 is 1. This is now plus 0 minus, anywhere I say sine is strictly 0, then I say cos x, but cos 0 is 0, so that's plus 6, minus right here, cos 0 is 1, so minus 4. So I have 1 minus 6 minus 4, which is minus 6 minus 4 is 10, negative 10, which is 1 minus 10 is negative 9. So now I can put in my final answer. So now I can tell them f of x is equal to f of 0. F of 0, remember, this is the formula we're using. F of 0, remember, is 1 plus f prime of 0. F prime is 0, so 0x plus f double prime. F double prime is 1, so then now plus 1x squared over 2 plus f triple prime, which is 0x cubed over 6. Then we have minus 9x to the 4 over 24. So in that case, it works out to be 1 plus x squared over 2 minus 9 over 24, 3 into itself, 3 times, 3 into 24, 8 times. So it's really 3x to the 4 over 8. That's the answer. Alright? So it simplifies to be this. Now, if you want to just double check your answer, right? I love when you double check. I would, by the way, you notice a lot of questions I was doing like 2 methods and double checking, and in a pure maths exam, you don't have time to be doing all of that, but for practice, you can, right? To make sure you understand. All right, and yes, guys, I'm working in a dark environment. I'm not gonna turn on my light. Some persons usually like comment and say, your room is dark or something. It's okay, guys. Just focus on the mathematics. Once you can see the working out, that's most important. I like to work in a dark environment because my eyes are light sensitive. So I tend to try to be in more darker spaces. Alright, so I'm really sorry for those who like when everything is bright, but I can't manage the brightness because my eyes are sensitive to light. Alright, so I have to tint my glasses and all of those stuff. So just to continue now, plugging in, you can test it to see if your answer is right. So our answer we got was 1 plus x squared over 2. Our answer was 1 plus x squared over 2 minus 3x to the 4 over 8. You can check it by trying maybe f of, let's put x as 0.5. Remember, just testing. And your calculator is supposed to be in radians. So testing it, 0.5, look at this. 1 plus 0.5 square multiplied by the cos of 0.5. This is what we get. And then our estimated answer should also give us the same thing. So I'm going to bring out another calculator, and the estimated answer should also be the same as this, or at least in the same ballpark. It should be similar. Alright, so I'm going to bring out the next calculator. It should pop up in a bit. So here it is now with the estimated calculator. 1 plus fraction button 0.5 square over 2 minus fraction button 3 times 0.5 raised to the 4th power over 8. It should be roughly the same, and it is roughly the same, so we know we're correct. Nice. So guys, that's how you check your answer. You should get roughly the same, all right, because it's an estimate. It's an estimate, all right. Notice it's up to a third non-zero term. So you could go up to 5 non-zero term. It's more accurate. Now we're in module 3, the easiest module. I'm going to try to go a little bit faster so that we don't pass the 3-hour mark for this video. Calculate the determinant. I'm going to use, I always like to use row 1. So using row 1, the determinant of the matrix M is 1 times, cross out the row and column with this 1 in, you get 2 minus k negative 1. Then minus 1 times the determinant of, cross out the row and column with this one now. So if we do that, right, you would leave back with 1 minus k 1 negative 1. Remember, it's this one will cross out just to show you again. Right, so we'd have 1 minus k 1 negative 1. Then the last one now we cross out this, right? And so we leave back with 1, 2, 1 minus k. And because this is minus, it is really plus negative 1. And then we have 1, 2, 1 minus k. And in this case now, we simplify this. Is 1 times 2 times negative 1 is minus 2. And then minus, this is now minus negative k. So it is minus negative k times negative k is of course k square. Remember, it's AD minus BC. Then minus 1 times negative 1 is minus 1. Then minus and minus become plus k. And right here is minus 1 in bracket, negative k minus 2. So if we simplify it, determinant of our matrix is, expanding the bracket, this is minus 2 minus k squared. Negative and negative is plus 1. Negative and positive is negative k. And this is now plus k. And this is now plus 2. Look what cancel. You notice minus k and plus k cancel. And minus 2 and plus 2 cancel. So the determinant of the matrix is just 1 minus k squared. That's the answer. Easy. 1 minus k squared. Alright. Now it says, hence or otherwise, determine the values of k for which the system has a unique solution. Now determine the values of k for which it have a unique solution. So let me see. Alright, so using row echelon, let me see, just 4 marks. So it will have a unique solution. So we'll have solution when the determinant is not equal to 0. So in that case, to list out all the possible values when we're going to get a solution is 1 minus k squared. 1 minus k squared, when that's equal to 0, we're getting k squared is equal to 1, and so k is equal to plus 1 or k is equal to negative 1. So it has a unique solution when k is equal to all values, when k is an element of real. However, k is not equal to 1 and k is not equal to minus 1. So k can be real values, but just not 1 and minus 1. That's when we're going to get some unique solutions. Easy. Now it says, using k as 2 in this matrix. Using k as 2, solve the system of linear equations by reducing it to row echelon form. So when k is 2, the system becomes 1 plus y minus 1 equal 1. By the way, this was 1x. Then we have x plus 2y minus 2z equal 0. And then we have x minus 2y minus z equal 1. Alright, and we need to solve it when case this value. So using row echelon form. So using row echelon form, this is now 1, 1, minus 1, 1, 2, negative 2, 1, negative 2, negative 1, augment, this is now 1, 0, 1. Now we're using this form now, we're solving for x, y, and z. So in this case now, I like to get my lower triangles of zeros. I need to get my lower triangles of zeros. So in that case now, we can say the new row 2 is going to be row 2 minus row 1, and the new row 3 is going to be row 3 minus row 1. And we don't change row 1, okay? So not changing row 1, we'll put back row 1 as it is. 1, 1 minus 1, 1. Row 2, 1 minus 1 is 0. Then 2 minus 1 is 1. And then negative 2, just to be on the safe side, negative 2 minus negative 1, just to be on the safe side, is negative 1. And then 0 minus 1 is negative 1. Then row 3 minus row 1. 1 minus 1 is 0. Negative 2 minus 1, just to be on the safe side, negative 2 minus 1, which is negative 3. And then now, negative 1 minus negative 1, which is 0 here. And then now, we have 1 minus 1 is also 0. So now, remember, we're trying to get lower triangles of zeros. So this right here, we need, what do we need? We need 0 where the negative 3 is. So since we need a 0 where the negative 3 is, right, this can be 3 of this, then we add them. So now, we need a 0 here, so 3 times 1 is 3. Then I add them. So if I do that, right, I can say my new row 3 is going to be 3 row 2 plus row 3. So I put back row 1 and 2 as it is, 1, 1 minus 1, 1. Then 0, 1 minus 1 minus 1. No, this is still 0. Now 3 times 1 is 3. 3 plus, that's 0. Then take out my calculator because 3 times, this is negative 1. Then I add it to, of course, 0. That's negative 3. And this part is 3 times negative 1. And I add it to 0. That's negative 3. So from what we have here, we can finish it off right here. So from that, we're seeing that negative 3z is equal to negative 3. So z is equal to 1. In the next part now, x, well, not x yet, y rather. In the next part now, y minus z is equal to negative 1. So y minus 1 is negative 1. So bring over negative 1 by adding 1 to both sides. So negative 1 plus 1 is 0. So y is 0. And so then x plus y minus z, which is 1. And so x plus 0 and z is 1. So minus 1 is equal to 1. So x is 2. So our final solution is x is 2, y is 0, and z is 1. That's your answer. Easy, easy, easy. So your answer is what? X is 2 and z is 1. If you scroll back up, what's your solution? Your solution for right here is x is 2, y is 0, and z is 1. You can check it in any one. 2 minus 1 is 1. 2 plus 0 minus 2 is 0. Yeah, it's so easy. Right? So this is your answer and you're guaranteed this will work. All right. Part B. A bag contains 5 yellow pencils, 3 blue pencils, 4 red pencils. 2 pencils are taken out at random and are not replaced. So it's not replaceable. Draw a tree diagram to represent their respective probability. So the first thing is what's in the bag? In the bag, you have yellow. In the bag, you have blue. In the bag, you have red. Now, how many yellow? First thing, let's find the total. 5, 3, and 4. 5 plus 3 plus 4. 8 and 4 is 12. So first thing, probability of yellow is 5 over 12 for the first draw. Um, Afterwards, probability of blue is 3 out of 12. By the way, you don't have to write it like this. Let me gonna do something. I want to put the probability at the end, but it doesn't matter, alright? It doesn't matter. I'm gonna put yellow, blue, red. And this was 5 over 12. This is 3 over 12. And this is 4 over 12. That's for the first draw. Now for the second draw now, for the second draw now, for the second draw again, it can be what? Yellow, blue, red, yellow, blue, red, yellow, blue, red. Now, when you draw yellow, if you draw yellow first, then 4 yellow would remain. So it would be 4 out of 11. Now for the blue though, if you draw a yellow first, you still would have your 3 blue out of 11. And then now, if you draw yellow first, you wouldn't trouble your red either, so you'd have 4 out of 11. If you had drawn a blue first, you'd have all your yellow. If you had drawn a blue first, then one of the blue would decrease. So you'd have 2 over 12 or 1 over 6. And then for the red, you would have, well, none of your red would be troubled. Why get 1 over 6 here? 2 over 11, sorry. Ha ha ha, laugh at me. Now, always make sure you add them when you get back 11, you know. So 4 and 3 and 4 is 11. 5. Oh, this was a 4 red, sorry. Now, right here, if you draw a red first, you wouldn't trouble any of your yellow. That means you wouldn't trouble any of your blue. And so your red would decrease to 3 over 12. And that's your tree diagram. This is the second draw. Easy. How much marks for that? Please just be 3 marks. They give 4 easy marks. Now they say, determine the probability that at least one pencil taken from the bag is blue. So this says determine the I'm going to write it better here. Determine the probability at least one blue is drawn. At least one blue. That's what we're finding. So if it's a probability that we get at least one blue, you can use your tree diagram to assist you. So going back around here, getting one blue, it could have been you got yellow then blue, could have been you got yellow then blue, or it could have been in the case where you got blue then blue, or it could have been the case where you got the red then blue, red then blue. But oh, remember An alternate way to do it, this is my preferred way then, if you get at least one blue, so the probability of at least one blue, you could have done it this way as well. That means the blue must be selected. You must choose one blue. You must choose one blue out of how many blues? Three. You must choose one blue out of three. And then the remaining nine, you can choose any one divided by you choosing 2 from 12. So that will give you at least one blue. So you can work out 3 C1 times 9 C1, that's 27, divided by 12 C2, 12 C2, which is 66. That's your answer. So you could then put 27 over 66, which is 9 over 22. This is 9 over 22. That's one way to do it. Or you could work it out this way and say you get yellow, then blue, yellow, then blue. So that's 5 over 12 times 5 over 12 times yellow, then blue. If we went yellow, then blue, 3 over 11 plus blue, then blue. That's 3 over 12 times 5 over 11. And then plus red, then blue, 4 over 12 times 3 over 11. We'll work this out. And of course, remember, we're going to have to times it by 2 just to double it. And I'll explain why in a second. This is my not so preferred way, because it's a little bit lengthy. So this way, notice we're getting 7 over, or we get 7 over 22, right? So we get 7. I want to make sure everything was in place. If we got a yellow first, yeah. We got a yellow first. Just want to make sure it's correct. Yellow first, 5 over 12. Yellow, then blue. If we got a blue first, 3 over 12. Then blue next, 2 over 11. You see why it's good to look over? 2 over 11. This was supposed to be 2. Then if we get red, then blue, 4, then 3. So sorry, this was supposed to be a 2. So why it's good to check over? It's good to check over. You don't have time to check over in pure math. You're going to have to make sure you don't make as much mistake as I do here. You're going to have to be quicker. So that right there, notice we get water. So did we cover all case? Yellow then blue, blue then blue, red then blue. Now we need to look at other possibilities. It could be now blue. No, we didn't cover now the blue then yellow and the blue then red. So we need to add in those, the blue then yellow and the blue then red. So now we need to add in the blue then yellow and the blue then red. So I don't like this method. At least one blue is so. Well, this is looking at. This is not even complete yet, but this is my preferred way, the at least one blue. So at least one blue, this is when it is definitely one blue. Or I need to add it to plus over 66 when I choose definitely 2 blue out of 3 and don't choose any of the, I don't want to choose any of the other colors. Alright, and then that will give us my answer because, yeah. So let me just finish this way and then write answer for you. And I hope it's clear. Alright, I'm going to turn on the light because it's getting a little dark too for me. So, fraction button. This is now 3. Choose 2. The numerator over, well, times, of course, 9, choose 0, over 66. I didn't close the bracket. 1 over 22 plus 9 over 22. So when I work that out, 1 over 22 plus 9 over 22, the final answer, at least one blue, is equal to 9 over 22 plus 1 over 22, which is 10 over 22 or 5 over 11. Up here now I need to work out blue, yellow, and blue, red. Blue, yellow, if I win blue, yellow, I'm going to show you, you're going to get the same 5 over 11. Blue, yellow would have been 3 over 12, so that's 50. I'm just going to write it as 1, 15 over 12 times 11 plus blue, red now. We'll go blue then red. 3 times 4 is 12. That's plus 12 over 12 times 11. Alright. Now, that's it. So now, this answer worked out the first 3. I remember we had worked out the first 3 somewhere. Ah, boy, I'm gonna have to put in all of that again. That's so much. That's so 15 over 12 times 11. Since it's the same denominator, I'll just be. You just need to add the numerators. 326 over 12 times 11. Ah, stop doing separate because I don't have time. Plus this one was 12 plus this one was 15 and this one was 12. Ah, here we go. So you get the same answer, guys. So your answer is the 5 over 11. Guys, by the way, the only reason we go over time is because I always show you 2 ways in an exam. You don't need to be doing the 2 ways and all of them stuff there, alright? Get your answer and you move on, please. Now it says, determine whether the result of the second draw is independent of the first draw. So the probability of draw 1, determine if it's independent of draw 2. Now it's independent if the probability of your first draw intersect the second draw if it's equal to the probability of your first draw times the probability of your second draw. Now the probability of your first draw, determine whether the result of the second draw is independent of the first draw. Now of course it is independent, right? Clearly it must be independent. Just looking at it, it can't be dependent. But I'm going to turn on the light. Alright. Now, your first draw, as we said, must be independent of the second draw, clearly, right? They're not going to affect each other. Right? So we know it's independent, but you need to justify. So this is how you justify. We're going to show that probability of your first draw intersect your second draw. It's going to give you the same as probability of your first draw times the probability of the second draw. So we're just going to justify. Where's my pen? Where's my pen? Alright, so here we go. So let's look at the probability of getting a red and a red. Alright, this is just an example. So the probability of getting red then red. Right, see it here? To get the probability of getting red then red, we noticed that we'd have to work out what? To get red and red, we'd have to work out the probability of getting red on the first draw times the probability of getting red on the second draw. So So clearly we realize that we'd have to work out probability of, we noticed that we had to work out by multiplying it. We had to use multiplication rule, right? So to get red and red, we had to work out 5 over 12 times 5 over 11, right? So in that case, that is independence. So now we're going to give them the reason. That is a justification. So we're going to tell them, since the probability of getting 2 reds, we had to use the multiplication rule of probability. Thus, the 2 draws are independent of each other. That's it. It's really that simple. That's it. They're independent of each other. Nice. Finish. Now, last question. We're going to just fly through this one. Determine the general solution of this right here. I'm going to write it over so you can see it a little bit easier. Y prime plus y cot x equal e to the 2x. First thing, find the integrating factor, which is e to the integral of k dx, which is e to the integral of cot x dx, which is e to, when you integrate cot, remember this is cos x over sine x. When you differentiate sine, you get cos. When you differentiate sine, you get cos. And since the derivative of the denominator is in the numerator, it's ln the denominator. So it's e ln sine x. And then e and ln cancel each other, so our integrating factor is sine x. So now the solution is y times our integrating factor equal the integral of function of x times your integrating factor dx. So in that case, the function is e to the 2x. So e to the 2x times your integrating factor sine x, that's equal to y times sine x. Alright, and then we can put plus c. So now divide through by sine x. Dividing through by sine x, y is equal to e to the 2x plus, well, I didn't integrate, sorry, plus the integral of this. So I need to integrate that first. Now, to integrate this, we're going to have to use, I'll put the plus c after. To integrate this, we're going to have to use by parts. Alright, so how many marks? 9. Yeah, it's tedious. So in this case now, let's call this our I late is the rule. Remember, I late. Which one comes first? Trigonometry come before exponential. So u is now sine x and dv is e to the 2x. So du is cos x and v is, integrate this, we get e to the 2x over 2. So in this case now we have y sine x equal uv, which is e to the 2x over 2 sine x, minus the integral of v du, minus the integral of v du, which is e to the 2x cos x over 2. I'll factor out that and put half out here, dx. We're going to have to go again, this part using by parts again. So y sine x is equal to e to the 2x over 2 sine x. And I'm just going to call this part I as well. I. And this is now minus a half times in bracket. Using by parts again, this is a u. So since this is a u, I'm going to have to write it again. U is cos x and dv is e to the 2x. So v is e to the 2x over 2. And this right here is a du, which is minus sine x. So it is uv, which is e to the 2x over 2 cos x minus the integral of v du. Minus and minus become plus, and I can factor out the half and write it as half e to the 2x sine x dx. But at this point, this is I, This is y sine x e to the 2x over 2 sine x equal minus half times half is quarter e to the 2x cos x, and minus and minus, minus and plus is minus, but half times half is quarter I, where I was this right here. Alright, so now we actually get to evaluate everything. So that's it, minus a quarter of I. Alright, so in that case now we need to bring everything else to one side. Alright, so by the way, basically what I was saying, just to show it out here, I'm gonna bring it on the blue page because I needed one more page. I needed one more page to justify what I was doing. So what we were doing was we started with this, right? So we started by saying, I'm gonna bring it to the blue page. We started by saying integral of e to the 2x sine x dx. What I had worked out, I call it I first. We actually showed that this was equal to, we showed that that was equal to e to the 2x over 2, e to the 2x over 2 sine x, then I think it was minus half e to the 2x cos x. Alright, that is our I. Then now we had worked out e to the 2x over 2 sine x, then minus half, here so we had worked this out to be e to the 2x over 2 cos x minus, was it minus or plus? Plus half integral of half e to the 2x sine x. But this part again was I. So because that part was I, this is I and this is I. We basically have I right here and e to the 2x over 2 sine x minus a quarter e to the 2x cos x. And this right here, the half and half is minus quarter. Bring over minus quarter, it becomes plus quarter I over here. And so this is now 5 over 4 I. So if we multiply through by 4 over 5, we'll get I is equal to 4 over 5 times all of this. Right? 4 over 5 times all of that is I. E to the 2x over 2 sine x minus a quarter e to the 2x plus x. So what am I saying? What am I saying is this part here now. So this is our finally now. So our finally is thus y sine x is equal to all of what we had right here now, which is 4 over 5 all of this. So this is now 4 over 5 bracket 4 over 5 e to the 2x over 2 sine x minus a quarter e to the 2x cos x plus some constant of integration a. That's it. Finish. Well, of course, you can divide through sine x, but um, that's very tedious. Do you want to divide through sine x? No problem. So let's just divide through sine x for the fun of it. So y is equal to 2 into itself 1, 2 into this. 2 into this goes 2 times, so that's 2 over 5 e to the 2x. Sine cancel sine. Cos over sine is cot. And 4 cancel 4, so that's minus 1 over 5. E to the 2x. And cos over sine is cot x plus anything divided by sine is, that's what? 1 over sine is cosec. So k cosec x. So if you want to give that as an answer, that's fine. No problem. I hope this makes sense. Alright, this part now. Show that, we love these questions. Show that this is a general solution. So to show that this is a general solution, First, we'll consider the auxiliary equation. This would be u squared minus u minus 2 equals 0. And we're going to factorize it. This is u, 2 and 1. Signs are different. Bigger number get the negative. So u is minus 1 or u is positive 2. In that case now, your general solution, or some people like to say your complementary function, is going to be, complementary function yc is equal to, it is a e to the minus, well, ae to the 2x plus be to the minus x. After that, now we need our particular solution. So now, for the particular solution, we'll start by saying yp is, since it is 3e to the 2x, right? Since it is 3e to the 2x, it's 3e to the 2x, then we know that it's going to be in the form ke, it's going to be in the form ke to the 2x, and so our yp prime is going to be 2ke to the 2x, and our yp prime prime is going to be 4ke to the 2x. So in that case now, we can substitute it in the original y. So in that case now, it's going to be, remember it is y prime prime minus y prime minus 2y equal 3e to the 2x. So what we're getting is 4ke to the 2x minus 2ke to the 2x minus 2 times y is 2ke to the 2x equals 3e to the 2x. So in that case, 4k minus 2k minus 2k can't be that. That makes no sense. Do you see it? It makes no sense. So something is off there. We put y is ke to the 2x, differentiate 2ke to the 2x, yeah, differentiate 2 times 2 is 4ke to the 2x, this minus y prime, and this is presenting what? No solution. This right here is presenting no solution. So in that case now, we don't know how to get to this. How do we get to this at this level? All right, so right here, don't worry, no solution using this method. All right, and so all we conclude then is we conclude by trial and error that yp prime prime, we conclude then that yp, look what we're going to do in guys. We conclude that yp is equal to xe to the 2x. And now what you're going to do is justify it. They said show, right? Notice the conventional approach will not work. So when you justify now, you need to justify by showing that y double prime minus y prime minus 2y should be 3e to the 2x. That's what we're going to do. We're going to justify it. I need another page for the justification. So all we need to do now is differentiate this twice. So yp is xe to the 2x. So yp prime would be, differentiate that, that is, keep the first times the derivative of the second. So 2e to the 2x plus keep the second times the derivative of the first, which is 1. And then now the second derivative, y prime prime, would be keep the first times the derivative of the second, 4xe to the 2x, plus keep the second times the derivative of the first, so 2e to the 2x, plus differentiate e to the 2x to get 2e to the 2x. So this works out to be 4x e to the 2x plus 4e to the 2x. Now since we're justifying, we're going to plug these in here. And so y prime prime minus y prime minus 2y is 4x e to the 2x plus 4e to the 2x minus y prime now, and y prime is this, minus 2x e to the 2x plus e to the x. Then we minus 2 times our y prime, and our y prime is x e to the 2x, and what we indeed get is 3e to the 2x. So that's what we're supposed to show, alright? Now once you show that, then finally now, you have to tell them then now, so, I don't know why they don't give more space. So, our general solution, remember, it's y is equal to your complementary function plus your particular integral. So your complementary function we got was ae to the 2x plus be to the minus x plus your particular solution, which was x e to the 2x. Then now it says hence solve the differential equation. So hence solve it, all you need to do now is plug in x as 0 and all of them stuff there. Alright, so solving it means find the values of a and b. Easy. So first thing we'll start by saying y is a e to the 2x plus b e to the minus x. Don't worry about it disappearing. Plus x e to the 2x. So solving it now, first thing plug in when x is 0, y is 0. So 0 equal, this is at the point 0, 0. This is 0. Anything to the 0 is 1. Anything to the 0 is 1. And 0 times anything is 0. So this is one equation. Now the next thing they give us is the derivative. So we're going to have to differentiate now. Differentiating this now. So y prime is equal to differentiate this. We get, let's differentiate that is now 2a e to the 2x. This is now minus b e to the minus x. Then differentiate this using product rule. Keep the first times the derivative of the second. So 2 e to the 2x plus keep the second times the derivative of the first. So that's e to the 2x. Alright. And then now we'll plug in. Plug in now when the gradient is 7. So when y prime is 7, we're going to be getting 7 is equal to, remember, x is still 0. So we have anything to the 0 is 1. So 2a minus anything to the 0 is 1. Anything to the 0 is 1. But 2 times 0 is 0. Anything to the 0 is 1. So we get 7 is 2a minus b plus 1. Bring over that to 6 is 2a minus b. And we also have the equation a plus b is 0. So from these two, we can do what? We can add. By adding them, 0 is equal to 3a. Well, 6 is equal to 3a. And so finally, we conclude a equal 2. If we get a equal 2, then b must be, what is b? If a is 2, 2 times 2 is 4. Bring over, so b is negative 2. So hence, solve it. So our final answer is hence, what's the general solution? Y is equal to a, and a was 2. This is your final answer. 2e to the 2x plus, well, minus, sorry. So minus b, which is 2e to the minus x plus x e to the 2x. That was it. So we got our values for A and B, and that's it. Now, guys, I'm not gonna lie, this is probably the toughest pure maths paper I have seen in a good while. So this paper was actually a challenging paper I have seen in a long time, alright? But that's that. I hope this video is beneficial for those practicing. And you realize unit 2, you have to be on your A game. Alright, so that's it. Take it easy. Stay tuned.